Metals and nonmetals are two major groups of elements that you will often come across in your study of chemistry, and understanding their properties helps us see why they behave so differently in nature and in our daily lives. Metals are generally found on the left and center of the periodic table, and thus they usually lose electrons to form positive ions, while nonmetals are placed on the right side and usually gain or share electrons to form negative ions or covalent bonds. Because of this difference, metals and nonmetals show very different physical and chemical properties. Physical properties of metals. Metals are usually solid, shiny, lustrous, malleable, meaning it can be hammered into sheets, and ductile, drawn into wires. They are good conductors of heat and electricity because their sea of electrons can move easily. They are sonorous, ringing sound when hit, and generally have high melting boiling points and high density. Common exceptions to remember are: mercury is a liquid metal at room temperature. Sodium and potassium are soft metals you can cut with a knife. Aluminium is light but strong. It also forms a thin oxide coat that protects it. Alloys, mixtures like steel, brass, bronze, are often harder or more useful than pure metals. Nonmetals, on the other hand, can be solid, liquid, or gas at room temperature. Example: sulfur is solid, bromine is liquid, oxygen and chlorine are gases. Solid nonmetals are usually brittle, they break when hammered, dull in appearance, and poor conductors of heat and electricity. Some useful exceptions are: graphite, a form of carbon, conducts electricity because it has free electrons in its layers. Iodine is a nonmetal that looks shiny. Diamond, another form of carbon, is the hardest natural material. The chemical properties of metals are largely determined by their tendency to lose electrons and form positive ions. When metals react with oxygen, most of them burn or combine to form metal oxides. Many of these oxides are basic in nature, meaning they can turn red litmus paper blue by forming bases when dissolved in water, while some, like aluminium oxide, are amphoteric, meaning they can react with both acids and bases. Metals also show varied reactions with water depending on their reactivity. Very reactive metals such as potassium and sodium react violently with cold water to produce metal hydroxides and hydrogen gas, releasing a lot of heat, which is why they are stored under oil. Moderately reactive metals like calcium react more slowly with cold water to form calcium hydroxide and hydrogen, while less reactive metals such as magnesium, aluminium, zinc, and iron react slowly with cold water, but more readily with steam. Very low reactivity metals like copper, silver, and gold do not react with water at all. Metals also react with dilute acids such as hydrochloric acid or sulfuric acid to form a salt and release hydrogen gas. Although nitric acid often does not release hydrogen because it is a strong oxidizing acid that produces nitrogen oxides instead. Another important property of metals is displacement. A more reactive metal can displace a less reactive one from its salt solution, such as in the reaction zinc reacts with copper sulfate to form zinc sulfate and copper, where zinc, being more reactive than copper, replaces it from the solution. In contrast, the chemical properties of nonmetals are shaped by their tendency to gain or share electrons. When nonmetals react with oxygen, they form nonmetal oxides which are usually acidic in nature, meaning they can turn blue litmus paper red. For example, sulfur reacts with oxygen to produce sulfur dioxide, which dissolves in water to form an acidic solution of sulfurous acid, while phosphorus reacts with oxygen to give phosphorus pentoxide, an acidic oxide. Most nonmetals do not react directly with water and generally do not react with dilute acids to release hydrogen gas like metals do. However, some nonmetals like chlorine dissolve in water to form acidic solutions, and some can even react with strong bases. For example, chlorine with cold, dilute sodium hydroxide gives a mixture of chloride and hypochlorite. Another important feature of nonmetals is their bonding behavior. Nonmetals often form covalent compounds by sharing electrons, such as in water, H2O, carbon dioxide, CO2, and methane, CH4. When they combine with metals, however, the bonding is usually ionic, as seen in compounds like sodium chloride, NaCl, and magnesium oxide, MgO. To organize this behavior, Chemists arranged metals in the reactivity series, a list from the most reactive metals such as potassium and sodium at the top to the least reactive like silver and gold at the bottom. This series helps predict whether a metal will react with water or acids, whether it can displace another metal from its compound, and even how it can be extracted from its ore. Very reactive metals need electrolysis. Moderately reactive ones are extracted by heating with carbon, and least reactive ones may be found in their pure form in nature. One major problem faced with metals in everyday life is corrosion, the slow destruction of a metal when it reacts with oxygen, water, or other chemicals in the environment. The most common example is rusting of iron, where iron reacts with oxygen and moisture to form hydrated iron oxide, rust, a flaky substance that weakens iron objects. Copper develops a green coating called patina. Silver turns black due to silver sulfide, while aluminium, though reactive, forms a thin oxide layer that protects it from further corrosion. Corrosion can be prevented in many ways: by painting, greasing, or coating with plastic to block air and water, by galvanization, coating iron with zinc, or chrome plating to form a protective layer, by alloying metals like in stainless steel where chromium prevents rusting, or by sacrificial protection where a more reactive metal like magnesium is attached to iron so it corrodes in place of the iron. Thus, understanding the differences in physical and chemical properties of metals and nonmetals, their order in the reactivity series, and the causes and prevention of corrosion is essential in explaining their uses and behavior in daily life. Like, share, and subscribe for more science lessons.